Okay, so let's dive into this really cool paper from 2013. It's all about how researchers taught a computer to do something we usually think of as, well, uniquely human, to create. And I'm not just talking about copying something. We're talking about generating completely new stuff, from text to handwriting that looks spookily real, all by itself. Just take a look at this handwriting for a second. It's got its own little quirks and style, right? It kind of flows, it has personality. I mean, it feels totally human, doesn't it? But is it? That is the big question. And stick with me because by the end of this, you're not only going to know the answer, you're going to understand the incredible magic trick that actually made this possible. So, to get how an AI can learn to write like a person, we first have to wrap our heads around how it learns to do something that's kind of like dreaming. The core idea, like the paper says, is just so simple but so clever. You start by showing the AI a ton of real data, let's say thousands of examples of real handwriting. Then, you just ask it to predict the single next point the pen should move to. But here's the brilliant part. Once it makes that prediction, you kind of trick it. You feed its own made-up point right back into the system as if it were totally real. And this kicks off a chain reaction, where the AI is basically just riffing on its own ideas, one step at a time. It's dreaming. Now, these early dreaming machines, they had a huge problem. I mean, they were brilliant for a split second, but they were unbelievably forgetful. And what's so interesting here is the massive jump in thinking. See, the older models were basically just glorified copy and paste machines. They could only spit out exact things they'd already seen. But these new models, called Recurrent Neural Networks or RNNs, they were different. The paper calls them fuzzy, and it's a great word for it, because instead of just copying, they learned to blend and mix and match between all the examples they'd seen, and that is what let them create things that were genuinely new. But here was the catch. Imagine you're trying to write a sentence, but by the time you get to the third word, you've completely forgotten the first one. That's exactly what was happening with these RNNs. The paper uses the perfect word for it, amnesia. They'd get a few steps into making something and totally forget how they even started. So creating anything with long-term structure, forget about it. So, to fix this pretty crippling amnesia, the AI needed a serious memory upgrade. It needed a way to hold on to the important stuff for more than just a few seconds. And the solution was an amazing invention called the Long Short-Term Memory Network, or LSTM for short. Honestly, the easiest way to picture it is like giving the AI a little notepad. It has these special memory cells where it can jot down important context, things like, hey, we're in the middle of writing the letter E right now. And it can keep that note handy for as long as it needs it. This was the absolute key that unlocked long-range creativity. Okay, so with its new and improved memory, the AI was finally ready for its first big test. Could it learn to write completely on its own with basically zero instructions? And this slide is just a perfect illustration of how that whole dreaming process works. See, at every single step, the AI isn't predicting one exact spot for the pen to go next. Instead, it creates what the paper calls a cloud of possibilities. It's basically a little map of all the likely next moves. The brighter the area, the more sure the AI is that the pen should go there. It then just picks a point from that cloud, and the whole thing starts over again. So by stringing thousands and thousands of these tiny little predictions together, the LSTM network actually taught itself everything from scratch. It learned what a pen stroke even is. It figured out how to group strokes into letters. It even learned to mash letters together into words that look plausible. Like, they look like English, but they're totally made up. And the crucial part is, it could keep a consistent style and remember long-range stuff, like having to go all the way back to cross a T after the rest of the word was done. I mean, just look at the variety here. Both of these were generated by the exact same AI. One's all loopy and slanted, the other is way more neat and disconnected. This isn't copying, this is real creation. It's pulling from everything it learned to invent its own unique styles. So inventing its own handwriting is one thing. That's amazing. But what if you want the AI to write something specific? How do you, guide its dream so it writes out your name, for example? Well, this required another genius level trick, something the paper calls a soft window. The best way to think about it is like a little spotlight. You give the AI a sentence you want it to write, and the spotlight shines on the very first letter it's supposed to be writing. Then, as it writes, the AI learns how to move that spotlight along to the next character, and the next, all by itself. And you can actually see that spotlight in action right here on this heat map. That bright line shows the AI's focus, and you can see it moving so smoothly from one letter to the next as it writes. It's just this beautiful, self-organizing process. It's incredible. And the results were just stunning. The AI was making handwriting so realistic that, as the paper points out, when they did blind tests, people often couldn't tell the difference between the AI's writing and something written by an actual human being. And okay, for the final truly mind-bending trick, you can prime the network. What this means is you can show it just a little sample of a real person's handwriting. The AI's memory cells will soak up all the unique features, the slant, the spacing, how they make their A's. And then you can ask it to write completely new text, and it will forge it in that person's exact style. It literally learned how to be a master forger. So let's go all the way back to that first question. That handwriting I showed you at the beginning? Yep, it was 100% generated by an AI. This 2013 paper was so much more than just a cool party trick. Its core ideas, these networks that can dream and remember and be guided, they are the direct ancestors of the generative AI that is just exploding all around us today. This was one of the very first critical steps in teaching a machine not just to calculate, but to actually imagine.